Okay, Mick McQuaid here with Chapter 1 of our textbook, R for Data Science. Here's Chapter 1. And what I would like you to do is read over Chapter 1, and I'm going to go over some of it with you. These are the commands that are given in Chapter 1. And this is the ggplot2 cheat sheet, which we will encounter in Chapter 1. So there's the book, there's the cheat sheet, and then there's the code. Now this is in a text editor. You're going to use RStudio probably, but I'm going to use a text editor here, and I just activated an NVimR plugin for the text editor. The text editor is called Vim, and the plugin is called NVim-R, and it provides an R console here. So I'm going to use that. I'm going to cut and paste my commands from the text editor window into here, and you can do something similar with RStudio. And this just clears the screen. I don't need to clear the screen right now. And the first thing that the chapter actually starts kind of in the middle. Let's take a look back here at the model for the entire book. And the model for the entire book is to import things, tidy them up, and then go through this transform, visualize, model loop as exploration, and then finally to communicate. And that's so the chapters are sort of related to that, except that it starts with Chapter 1 right here, and you might wonder why that is, and that's simply so that you can get some immediate gratification and motivation, because a lot of this stuff here can be tedious drudge work, and it would be more fun and exciting to start with visualization. So we're going to start with visualization here. So the very first thing to do is to import the library. So I'm going to cut and paste this. And this is actually a kind of a multi-package or meta package that contains all these packages. So I'm importing all these packages into R. Now, if you don't get this, it actually says here what to do if you don't get this. You'll have to then say install packages tidyverse, and that can take a while because there are a lot of packages to install. And then you'll have to say library tidyverse. Okay, so the very beginning of this book suggests that we explore the data set that's within the ggplot2 package called MPG. So I'm going to say MPG, and it's going to show the first 10 lines, the first 10 rows of MPG. MPG is a rectangular array, a data frame, or a tibble as it's called in tidyverse parlance, but it's in any case it's a data frame with 234 rows and 11 columns, and the columns have names. The names are manufacturer, model, displacement, year, cylinder, transmission, drive, city, highway, FL, which I've forgotten what that means, and class. And these are the first 10 values for each of those variables. First 10 rows, and there are 224 more rows. And we could also look at this with the head function, and that gives us the first 6 rows. And we can control with head how many rows we see. And the very first step is to do a ggplot from this. So here's the code for the ggplot. I already typed it in here. So I'm going to paste that into the console, and it opens in another window. So I'm going to have to bring that window over here. And this window is square. Most of the plots in the book have an aspect ratio of about 4:3 or 16:9. And so I'm going to just alter the size of that plot. So this is a plot of displacement, which is in liters. So it goes from, I guess, 1.2 liters all the way to 7 liters. And then highway mileage, this is in miles per gallon. So the highest mileage is almost 50 miles per gallon, all the way down to this is probably, I don't know, Ferrari or something, or some kind of supercar that gets a gas mileage. Oh no, it could be some kind of a heavy truck also that gets gas mileage of less than 10 miles per gallon, way less than 10 miles per gallon. So this is a scatter plot, and it's called geom point, is the geom object. We looked at geom objects when we looked at layer of grammar graphics, layered grammar of graphics, excuse me. So, and the mapping is, the aesthetics are displacement on the x-axis and highway on the y-axis. Okay, and then, so we look at this plot, and we see, by the way, that it shows a negative relationship. We can immediately tell something about, and certainly our intuition would tell us that a larger engine gets poorer highway gas mileage. There are some outliers here, and we're going to explore those outliers later. And this is a graphing template, blah, blah, blah. There's a bunch of stuff here. I want you to read the whole thing, but I'm just going to gloss over it at a fairly high level and get to the stuff that we can type in here, the code. So the first exercise is to type this in. And what do you see? Well, you see nothing. So this is going to leave us with nothing. We would need to put some aesthetics here to make something visible happen. Then the next question is how many rows are in MT cars? I think it meant how many rows are in MPG, but I'll check MT cars, which is another data set here. And I can do dim for dimensions of MT cars. That tells us how many rows. It's 32 rows by 11 columns. And I can do the same thing with MPG. And for some reason it's not... Is it accepted? Yeah, there it is. Okay. So 234 rows by 11 columns, which we already knew. And we can find that out also by doing a summary of these. Gives us a little bit of information about each variable. There's for MT cars, and here it is for MPG. And the next question is actually about one of these variables. What does the DRV variable describe? Read the help for MPG to find out. So let's do that. That's question 3. So we're going to do that. And what happens is a new window opens up. So I ran the command here, and it opened a window here onto a description of MPG. And this is the case for most data sets that you'll find built into R, is that they come with a description that explains what they are. And you can see that DRV is front-wheel drive, rear-wheel drive, or four-wheel drive, and it's recorded by these 3 symbols, F, R, and 4. Okay, moving along to number 4, make a scatter plot of highway versus cylinder. So I've done that here. I'll open that up. And you can see it's not really very exciting to look at. It's got the highway mileage and the number of cylinders. Most of the cars have 4, 6, or 8 cylinders, although there are a few that have 5. And it says here, you might think that there are only 2 that have 5 cylinders, but actually there are more. What's happened is that any that have the same highway gas mileage are overplotted. And overplotting is a big problem. How do we tell? One of these could be a really tall stack of dots. We have no way to tell. So over here I did a better looking alternative called geom jitter that moves each dot a random amount away from the point where it's supposed to be. And so this gives us an idea of how many there are. And you can see there are actually, I guess there are 4. I thought there were 5 of the 5-cylinder jobs, but anyway, there are 4. There are other ways we can see this. We can go over that later. I want to stick pretty much to what the textbook is asking us to do, because I think it's a really fantastic book. What happens if you make a scatter plot of class versus DRV? Why is it not useful? So I'm going to do that. And class is two-seater, compact, mid-size, minivan, pickup, and so on. And drive is four-wheel drive, front-wheel drive, or rear-wheel drive. And you can see we have the same problem here, overplotting, that each of these dots may be a stack of dots. We really just don't know how many dots are in here. So I've done the same thing again here with the jitter, just so we can see. And of course you can see that, yes, indeed, many of those were rather tall stacks of dots. And there are other ways that we can do that too. That's just for convenience. Okay, now the next section of the book is called aesthetic mapping. So there are roughly 7 sections here in this chapter, one for each of the 7 major aspects of the layer, the grammar of graphics. So aesthetic mappings is the first one. And I mentioned we had some outliers here. And let's suppose that we would like to figure out how, what it is that these outliers have in common. What is it that makes them stand out? And we can use an aesthetic that is something that's visible. So for example, we could use different symbols. We could use different colors. And here he's used different colors. And so I'm going to do the same thing here. And that is exactly the same plot as down there. And you can see the outliers quite easily, that they're all two-seaters, or almost all but this one are two-seaters. So there might be something different about two-seaters. These could be like super powered sports cars. So they have huge engines, even though they only seat 2 people. Okay, so now there are plenty of other things. So what we did here to get the color was we said color. The aesthetic for class is color. So you can see over here that this is class, and all these colors are used to represent class. We could instead use size, and that's the next thing that our authors do. And you can see that size is not that great of an aesthetic mapping. And the reason that it's not a great aesthetic mapping is because it's ordered. So the size is getting bigger and bigger here. But these aren't getting bigger and bigger. These are categorical variables. This is, or I should say, this is a categorical variable. Class is a categorical variable. And so all of the instances here are categories. One is not bigger than the other. I mean, they may in fact be physically larger than others, but they're not coded in any way, in any kind of ascending or descending order. And if you were to try to code them in an ascending or descending order, it might be difficult to do that because you've got both weight of the car and the displacement of the engine at play. And sometimes a large engine might be in a small car, as is probably the case with some of these two-seaters. So it might be difficult to turn class into an ordered variable. It's a categorical variable. And so we got a warning message here saying that using size for a discrete variable is not advised. And a warning message allows us to proceed. If it had been an error message, we wouldn't have gotten anything. So a warning message is less severe than an error message. Okay, now another possible thing we could do is control the alpha channel. So this will control the transparency of the dots. See, we're still on the geom point geom object. So we're using points, and we're using dots, and these are almost transparent, and this is almost completely opaque. So we've binned, that is B-I-N-N-E-D, binned the categories into these different classes of what is really an ordered variable. This is not, I mean, transparency, alpha transparency is actually numerical, and this is not. So this is also inappropriate, although we didn't get an error message this time. Here's yet another one. This is shape, and we're going to have a slight problem with shape It says that the shape palette can deal with a maximum of 6 discrete values because more than 6 becomes difficult to discriminate. You have 7. Consider specifying shapes manually if you must have them. So what we find is that there are no symbols for the last category. So it's given symbols in order. This is symbol number 1, number 2, and so on in its list of symbols. And we can actually refer to them. If we want to highlight something, we can refer to these symbols by their numbers. And it's only given 6 symbols, and we could color them. We could manually do things so that we get a 7th symbol. The problem is that it's hard for the viewer. Okay, and we can set a manual aesthetic mapping, and so I'm going to do that here. And what I've done here is set an argument to geom point of color equals blue, and that makes all the points blue. Okay, so that wasn't an aesthetic, that wasn't in this group of aesthetics here. That was actually outside of that, an argument to geom point that allows us to color everything or do something to everything. Now we have some exercises. Oh, and yeah, Hadley is from New Zealand, so the one co-author of this and the author of ggplot 2 uses a lot of British spellings and British syntax. Okay, so we looked at all of this stuff here. As I say, I'm going by this at a very fast clip. I want you to go over it in some detail. Okay, what's gone wrong with this code? Why are the points not blue? And this is subtly different from from what we just looked at. So look at this one. This worked. This made them all blue. In this case, they're not blue. They're the same color as 2-seater was. In other words, they're color number 1. So here's the messed up code. I'll just run it to verify it. Yeah, this is the messed up code. So you can see that color is far from being blue. What's happened here is that we accidentally put color equals blue inside the aesthetic mappings. So now blue has, color has something to be colored by. In other words, I could make color be by class, for example. Let me just do, did we do color by class? Yeah, I think we did. I'm just going to do that real quick. If we did that, we would get a good result. Okay, but blue is a constant. Blue, in quotation marks here, is a constant. And so it simply maps the first color in its list, the color that it gave to 2-seaters in class, to this constant, which it calls blue. It has no concept of what the meaning of the word blue is. Okay, so there's no correspondence between the word blue here and the color blue. We can actually set colors up the way we want them, but not like this. This is an error, and a frequent beginner error, I think. Okay, question 2. Which variables in miles per gallon are categorical? And which are continuous? Hint type question mark MPG to read the documentation for the data set. So that is one thing that we could do. The other thing that we can do is this. I'm just going to go summary MPG, and you can see here this is categorical, categorical, ordered, 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 categorical, categorical, ordered, ordered, categorical, categorical. And by continuous, it I think construes integers as continuous here. I'm not really sure. Certainly the only floating point number is displacement. The others are all integers, but I think that that's what the authors mean by continuous. Okay, and then how can you see this information when you run MPG? So if we just say MPG, oops, we have to do it right. You can see that underneath the headings are the words character, character, double. That's the type of floating point number this is. It just signifies the size of the floating point number. int signifying integer, int, character, character, int, character, character. So you get the same information from looking at the summary. And we could get the same information from saying question mark NPG. Okay, map a continuous variable to color, size, and shape. So that's, I'm going to do 3 separate plots here. And what's going to happen is ggplot will bin the colors in the first case. So color is the first one I'm going to do. Okay, so each bunch of colors is in a bin. So this bin is going from 6 to 7, and it's one color, and then 5 to 6 is one color, and 4 to 5 is one color, and so on. And it's just a uniform color palette ranging from blue to black. And we could make that, we could force that to something else, and we'll learn that later. We can make things look really cool. Okay, now we'll do size. And size we've seen before is kind of a drag. It's a little bit better here because size is ordered and displacement is ordered. So that's, that's in a way it's intuitive. The engines that are the smallest have the smallest dot. The engine that's the biggest has the biggest dot. Okay, and then shape, oops, I gave it away here. So I try shape, and I get an error message. A continuous variable cannot be mapped to shape, and nothing happens. I'm still seeing the same plot that I saw before. What happens if I map the same variable to multiple aesthetics? Well, we've already seen that. We've already done that. We did that here with mapping x to displacement and color to displacement, x to displacement, size to displacement. And what happens is we just get some reinforcement. So it's fine to do that. And it's actually, it can be very useful practice. What does the stroke aesthetic do? Okay, so the stroke aesthetic I'm going to find out in geom_point. So I'm going to look, it says hint use question mark geom_point. So I do that and I get a description of geom_point, and I basically just went down here until I found stroke. There's actually an example using stroke. So I just did that example to see what it would look like. Did I pass it already? Here it is. So I just did that example right here. And what I got was I've colored the stroke white, and I've made the fill black, and the size equals 5 stroke size. That's the total size of the dot, and stroke equals 2. And I can make the stroke wider, so I can have like a really big white saucer around these. Okay, what happens if I map an aesthetic to something other than a variable name like aesthetic color displacement less than 5? So I'm going to do it with MT cars, and with weight less than 3.5. This is weight in thousands of pounds. So this is all the cars that weigh less than 3,500 pounds, and miles per gallon and displacement I have here. So and this displacement must be in is this, well, it's not in liters, it's in centiliters. I don't know what, I can't quite guess what that displacement is. Maybe it's cubic inches, come to think of it. And miles per gallon along this side. So what you can see is that we've got actually a Boolean here. Weight is less than 3,500. It mostly gets good gas mileage, and weight greater than 3,500 mostly gets poor gas mileage. So what's happened is that this expression right here has resolved to a Boolean value. Okay, weight less than 3,500 has resolved to a Boolean value. And so color gets that Boolean value. So color can take on either true or false depending on the value of that expression. So that's an example of a very powerful kind of expression. We can use expressions like that all over the place to get subsets, to divide our stuff up. Okay, so that's the end of that. The next section is called Common Problems. I'm going to go over that in the next video. So let me just thank you for your attention, and that's that.